Hello, everybody, and welcome to Sparring Partners. Today, it's a special one because we often talk about different solutions, different things, but today is going to be more on the visionary part, and we're going to be talking about 6G, but we're going to talk about 6G in a different way. As many of you know, I've taken a sort of I haven't actually talked that much about 6G, but the issue is that a lot of people see 6G as well, they wonder, do we need 6G? What do we need it for? 6G is just going to be a continuation of 5G. And what we're going to talk about today is, which is the visionary part, which is 6G is not about, well, it is going to be partly about the air interface, but it looks like the air interface is not going to be fundamentally different from 5G. But what 6G is going to be about is to start developing an entirely new concept of connectivity, which is already underway, but what 3GPP can do is to enable it. And I know that that sounds very kind of loofy and high level here, but we'll get to it and make it a little bit more concrete. And to that end, Colby Harper will be our guide to this unknown. And I've known Colby for a very long time. We've been working together on previous projects, and he is the founder and CEO of Pathfinder Wireless. But before we get into everything, Colby, thanks for being with us today and tell us who you are, what you do, and why you got into thinking about this.
Okay. Well, first of all, thank you, Monica. It's a pleasure talking with you again about yet another, forward-looking, what's happening in the ecosystem and industry topic. Uh, Pleasure as always. So, Pathfinder Wireless, we're strategic advisor for Next Gen Wireless since the 2G era, and that's both kind of commercial as well as private wireless, kind of advanced wireless networking of various sorts. Um, we work in standards, spectrum, and we co-develop at times, depending on the specific need of our partners and clients. Obviously more lately, it's around 5G and 6G and non 3GPP technologies as well, terrestrial, non-terrestrial, etc. We probably have, I would argue, a specialty in the adaptive control of complex systems. And sometimes those complex systems are the control plane, right, of many of these advanced wireless networks. And sometimes there are other aspects of any complex distributed control system, et cetera.
Yes, so complexity is your business, and also new technologies, and we've been talking a lot in the past about sharing and different networks working together. So there's kind of the sort of in a way the beautiful but also ugly details of getting everything work together, which is often, the idea is great, but to get it to work is hard.
Yeah, the technical complexity is really secondary there as we've experienced.
Absolutely. So let's get to talk about 6G. So we're not going to talk so much today about the air interface of 6G. It's going to be its own thing. But what else is there that is, it is going to be important in defining a new way we look at connectivity?
So let's start with this, but I would like to get your take on it because there are a lot of moving parts here, right? How they
Mhm.
relate to each other. But if we look at specs and standards and wireless systems as kind of enablers versus applications, which is not an unreasonable way to look at it. I think that the challenge for those creating this future and trying to envision this future is the central organizing principle of what they're trying to do. So are we enabling high value for others, or are we creating the value that others probably, in my opinion, are better suited to create and discover? So, where in the past, just to get things launched at times, we would try to create some of the value, right? Though it didn't always work that way. Uh, we probably succeeded most in creating or fostering an environment where others could create value, right? Doing the plumbing. I've often tried to describe, when asked by all kinds of different folks, friends and otherwise, what do I do for, you know, more than a generation now, right? For 20, 30 years. I'm kind of a plumber, right? So I try to, and we collectively try to provide plumbing to you so that you can then determine what you're going to do with the water we bring to you, right? And is it filtered? What whether you make a wonderful meal in a kitchen, whether you're doing industrial processes and chemical processing, or whether you're using it for sanitation or irrigation, whatever, I don't know, but I want to foster an environment where you can help us help you, literally, right? So we're plumbers. I think in the 60 era, remembering that we are plumbers and coming up with more horizontal enablers that allow uh, this value to be created, and not just one given technology, but multiple technologies. Right. So in the case of IMT 2030, which is not the only definition of 6G, but it's one pretty good one, they talk about HETNet, heterogeneous networks. That's many different types of technologies, radio technologies that, at least the concept is, they'll work together. Somehow they will collaborate. And perhaps advancing that collaboration, fostering that environment such that real value can be discovered and created by those that are the sources of that value. I think that's one of the best things we could do.
Yeah, and absolutely. And I really like your analogy with the plumbing. Even though it might call to some people in mind the dumb pipes, I think that actually the pipes are not dumb at all. You need intelligent pipes, and there is a huge amount of value in the pipes. But if I extend it a little bit, is that the plumbers of the previous generation would have, one source of water, one faucet, that was it. That's all you need for water. Now, you as a plumber, you're going to have to deal with different sources of water, and they all might come out of the same faucet or different types of faucets. So it's a many to many issue, but it's still water. And the water is connectivity, right? So what we're trying to do is to get connectivity, but connectivity comes from different sources. So, satellite, Wi-Fi, cellular, sensing, whatever. And then it gets delivered not just by a cell phone. It could be a drone, it could be a sensor, and what. So your life got much harder as a plumber. Is that a
Yeah,
fair definition?
absolutely fair. And my and our, I'll say, the collective ecosystem response has been earnest and often, a successful response. But there's some areas where we probably want to adjust going forward in terms of our kind of natural response to that complexity.
Yeah. So, okay, let's go and talk about the different sources and how do we deal with the complexity? So when you have, different different networks with obviously separate air interfaces. So if you have, satellite and cellular, say just this, and which is the simple one, relatively speaking, because there is way more than that, or sensing. How do we think about it from, say, a 3GPP point of view or a standardization point of view of bringing them together? Because the value of satellite is much more, it's enhanced by the fact that it can talk to cellular. And similar, the value of a cellular network is enhanced by the fact that it can talk to satellite. So there is a value that we are creating by bringing them together.
So if I can take it at kind of two levels. The first is just generally, what does collaboration mean for them? And I
Right.
agree. The satellite non-terrestrial, the high altitude platform non-terrestrial, even the low altitude, right? The drones you mentioned
Mhm.
and the terrestrial, but especially kind of if we bookend it with satellites, LEO, MEO, GEO, and VLEO, very low, uh, with the terrestrial, let's say terrestrial 5G or terrestrial Wi-Fi, to your point, of multiple different radio access technologies. Uh, Allowing them, what does collaboration mean? One of the things we know is that they need to have some shared concept of identity to some degree. We don't need to go into that here. If you'd like to, we could. But one of the areas I'd like to highlight, it kind of draws out some of these issues, is timing, right? So what can 3GPP and some others do is working on a shared concept of timing, clocks, synchronization, to allow collaboration across, for instance, a LEO constellation and a terrestrial aspect. Uh, Concrete example is we can go into the details of how it works, but timing advance is an essential component of modern, generally 3GPP, for instance, 4G, 5G systems, of how they operate, how they allow you to make sure that if you're out on the edge of a cell outside, that call completes, that the interference is somewhat mitigated across different cells, that your performance, wherever you happen to be in the footprint of, for instance, a 5G carrier, private or public, but especially public, this timing advance, this timing knowledge that's shared across your handset and the base stations, so that you can coordinate and have a reasonably efficient and also reasonably high throughput with managed, to some degree, managed interference. This is all, though, native just to the 5G system. Where we need to have some level of collaboration or coordination across, say, a LEO constellation, uh, whether it's a rural area or mobile transport, when you're outside of the urban areas, the the coordination requires this lowest level plumbing enabler of some level of knowledge where the terrestrial systems kind of know what the clocks are and the timing and the synchronization out there on the satellites, because they're moving really fast, right? In 90 minutes, they're going to go around the world in most cases, like Starlink or others, right? It's different for GEO, but for LEO, that tends to be around there. That fast moving means that they have physics challenges that are outside of traditional radio challenges. So relativistic effects, they make the clocks run faster. So these coordination decisions that are happening on the terrestrial side as well as in space, and the ground component of the satellite network, right? Uh, though they need to have some shared sense of time and of frequency. Without a shared sense of time, it doesn't have to be perfectly exact, but right now it's not too tightly coordinated. You miss coordination opportunities. You have 5+%, depending on the models that you look at, of spectrum reduction based on that. And that's a minimum, right? It goes up from there. There are various ways to bring that down. So anyway, the idea of enabling a conversation between the systems and designs and kind of culture, if you will, of the satellites, and the system and design and kind of culture of the terrestrial components, 5G, needs to be specified, right? So timing advance is not the same for all radio access technologies. Wi-Fi has a different sense of how it thinks of and manages timing than satellites. Even 3GPP compliant satellites in the, for instance, NB-IoT, which is going to be with us for a long time, started in 4G, goes to 5G, it'll be with us in 6G. It has its own sense of timing advance. It's somewhat coordinated, but across all of these, if we raise it up one level, kind of a meta level, and we call it timing intent, how do we share what we think about timing? What is your clock? What is your frequency? And what do you expect it to be across them. What does this bias? What's the impact? Why does this even really matter, right? It's not just about spectrum efficiency. That's one thing, right? It's not just about coexistence. It's about, you brought up sensing. It's about the, the collaboration for more advanced and precise sensing. Concrete example. If we're off by a few nanohertz because on the frequency side, because we're off on the clock side, because we're out of sync or out of phase, that can, maybe in one moment it doesn't matter that greatly, but because we've got all these satellites moving around, and of course on the ground there's movement too, but across all of that, the relativistic effects of the clock, uh, they impact. It starts out as a few nanohertz. It becomes, 3, 4, 500 millihertz. And it can turn into something that is not visible to our conceptual microscope, into something that you could hold in your hand. Eventually, after a day or so, it might be like a pea size or a marble size, even. If you think about that, this matters. So, what does that pea or marble do if it's too large and we can't say what it is? That vagueness. If you're a farmer and you're using satellites for sensing or to understand kind of where your irrigation is, and you see those circular
Yeah.
irrigation or
Yeah.
other type, right? Right. You're trying to make decisions on chemical assisted agriculture, on good chemicals, green chemicals where you can, right? You need to make these choices for efficiency and effectiveness so that you can minimize the chemicals you use, for instance, or the nutrients that you add to the irrigation. If you don't know where that is, right, where your irrigation plant is at a given time, if you only know within 100 or 300 meters, you're unable to execute the precision agriculture decisions and the early, efficient, more green, more effective choices that must be made to selectively and in a precision manner apply. So that 1p of nanohertz and timing that's mismatched across satellite and 5G can turn into hundreds of meters of uncertainty. Now, if we take care of that and we allow some collaboration, right, some timing intent sharing, you can start with simple prediction. You can move to more concrete locks where you even ultimately, only where needed, you might lock clocks, from certain satellites to your terrestrial component. But you don't even need to go that far. You can shrink down that knowledge down to the meter level. And the 6G era requirements, at least from an IMT 2030 target, gets us down to centimeter level. So you can get value out of this without going to quote 6G, but starting with collaboration across these different radio access technologies for timing, just like we do or trying to do with identity, could be one area that adds great value and kind of fosters this environment for all these other verticals, consumer individuals, as well as vertical industries to take advantage of this plumbing that we provide. Well, you said the intelligent plumbing. I believe that timing and timing intent is one of those things that makes the plumbing more intelligent.
And I would say this is an excellent example to sort of start understanding what is needed, which is not necessarily, a faster air interface to allow a service like online gaming or whatever the case might be. It's kind of a more, I would say, general purpose, but fundamental, because each network has a different sort of conception of time. This is kind of becoming a little bit more philosophical than maybe we're planning to, but the way you define time, like if you're, for instance, as you said, mentioned Wi-Fi, but if you're Wi-Fi indoors, you cannot use synchronization by satellite.
Yeah.
And if you are outside, clearly that's a completely different business. So not only you need to coordinate, but the input or what time is for each network is fundamentally different. So it's not a question of just let's agree that we're using. It's not like using being on the same time zone kind of thing. It's just that the time is defined different. The resolution is different. The accuracy is different. So location then too, because obviously location is also important. But so For sensing, I guess location is just as important. But the way you measure location in indoor location versus an outdoor location, or by satellite and by, it's completely different. So the coordination is just a question of, the way I see it is a question of having the right interfaces to allow a different conception of time to talk to each other, which is a completely, I mean, and time is one thing, but then there are other dimensions too. And so it's a very different way to look at the role of 3GPP. It's not just to define like an air interface standard, but to define the right interface that allows different elements to talk to each other. And it's not just in different vendors, which obviously that's part of it. It's networks doing different things, correct?
I I agree, and I'm glad that you said, the meaning of time. It is philosophical, but that's also part of the semantic, the meaning component. If we don't have that, we're talking past each other. And I
Yeah,
hadn't even thought
exactly.
of it in the sense that up front, the pre-negotiation before we even come to this is the information element that we share. We get down to this specific element, and this is the bit pattern that we use if it's hardware, and this is the API if it's software, blah blah blah. But even before that, what is the context? What is the meaning? What do we mean by time? If we don't do that, we will be talking, the translations won't work well, I would agree. So I think it is useful to take the philosophical uh, approach at first, which is what is the semantic, what is the concept we're talking about of time, and how do we uh, constrain that and make sure that on either side they know what we're talking about. And that's more than just one discrete variable. That's a group of characterization elements to really understand each other.
Yeah.
Am I
And then
tracking?
and time is such a, and time, location, and I guess security is another one. There are concepts that are so broad that they are not there to support a specific use case. Because one problem that I have with a lot of people just to say, well, we need to develop 6G standards to support specific use cases. We don't know what the use cases are going to be. We're going to be surprised by that. I've always been surprised. As far as an analyst, you're supposed to know what the future brings. But, I've been, did I predict that video was so popular? No, I didn't. Did I see the short video coming? No, I didn't. So sorry about that, but I didn't. But I am glad that we have networks that support it, even though most people, I don't know that anybody really was predicting short video in the same way they didn't predict SMS when it came out. So, but we need to have a network that allows you to do that. And I think that, this work about with timing, security, location is actually going to build the foundation, the plumbing foundation, if you wish, to allow us to explore those kind of things that is not up to 3GPP to think about, like the use cases.
No, in fact, it's
Yeah.
even perhaps a little distracting from because we have enough to do. We all have enough to do. Just really making robust and thorough these horizontal enablers, right? That's the job, I believe. Interfacing, fostering interfaces with these more kind of profile-oriented, horizontal uh, standards development organizations, but it could be market development organizations, right? But these sectors that know what they need and are better able to characterize what success and value is from these intelligent pipes and intelligent plumbing that we provide at kind of the horizontal enabler. That's 3DPP, that's IEEE 802.11 and Wi-Fi Alliance kind of stuff. That's the satellite community, right? The mobile satellite service MSS community in particular. Some of that has a Venn diagram overlap with 3DPP technology. Some of it rightfully will just continue on its own as a community. We might even, and it's a little bit broad reaching, but we might even bring in the Bluetooth community in the sense that there's
Yeah.
crossover there. One of the things I found really instructive from the Bluetooth community is that they have their very clear horizontal enabler components. right? And then they're very tightly specified, right? Very deterministic kind of standards. The conformance is like this. And then there will be these vertical applications. We know some of them, right? There's the car version. So when you rent a car, it tends to work pretty
Yeah.
consistently and well. There's the audio component. There's other components. There is a component for mobile platforms like in the airline case, right? There's these different verticals that create profiles, and they know what the KPIs are that matter. They know better, I should say, what the value is. They discover, and also they're like mini SDOs or special interest groups. Something similar happens to your point earlier about the separation of the horizontal plumbing versus where the value gets created and discovered. In the industrial side, right? They've got the standards that allow the collaboration and coordination, the basics that are really tight. And then they have various types of profiles. This happens in timing too, but for different types of equipment, because different users have different sets of needs. And for them, they know that these are the KPIs that matter to us. We live and die by this, every day, every year, every quarter, financially as well as operationally. Um, they can find, if we foster an environment for them to do so, they can find whatever the killer apps, as you noted earlier, are in the 6G era. It reminds me of a number of years ago when you were kind of taking me through some of you mentioned SMS and
Mhm.
some messaging evolution in standards, both specified formal standards as well as external standards. This was a few years ago in the kind of the as 5G was ramping up days, Monica. And I think you mentioned SMS. I think there's something there too, right?
Yeah, 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 yeah. Well, it's like oftentimes you just build something. I mean, and this is, I guess, the issue that I have with some critic of 3GPP in general, that they specify too many things, and most of the whatever the specifications are, they never get used. And it's like, well, I don't care. But some of them are used, and it's not clear that you know ahead of time which ones are used and not. So, for instance, if you look at MIMO, there was a lot of people that didn't believe that MIMO would ever work, right?
It
But
took
then
a
you
while,
keep
but yeah, it
going.
worked.
Yeah, yeah. You keep going, and then eventually, but then there are probably some other examples of MOMO-like things that sound great, and yet they never go anywhere, and that's fine. But you need to try to let people see what is that they can do. Now, let's go back to sort of 6G and sort of just to give some other examples. So clearly, time synchronizations and but basically timing across interfaces, it's important. How is 6G dealing with the issue of getting different technologies to work together in general? What is the framework there, the conceptual framework that 3GPP is using to move towards that?
Well, so on the 6G level, there are a couple things informed by some earlier experience of how do we incorporate vertical. Started with mission critical communications, which we tackled very directly, including other types of required, regulatorily required. Maybe it's CALIA, maybe it's critical 911, et cetera. Those sorts of communications. Those were kind of our first vertical in a sense. So, but after that, of course, you have autos and you have to degree satellite was sort of a vertical that's now integrated to a degree. Uh, but it was a response to we have to learn to work together. So, what have we learned, and how are we doing things a little bit differently in the 6G era of 3GPP? I would suggest a couple things. One, um, took the service-based architecture approach and these different sort of capability interfaces and APIs that were very network-centric and very tied specifically to the lower level of the radio access technology, and started to more increasingly make them more generic uh, and expose them. So that was kind of the initial for us. It's like we realized we can't define all these use cases, even though we have folks coming to us over the last number of years, since release 15 and before, right? But especially the last while. So let's, as 3GPP, and then some very rational, healthy responses from the rest of the standards ecosystem as well, we'll get to in a moment. The exposing these APIs, we certainly did it for billing for ourselves and others, right? So we have that group, but exposing the general capabilities. We went just so high, and then allowing the voices of these verticals to come into 3GPP still kind of works. Or kind of some special interest groups, kind of cohorts that you get the auto coming in to share. This is what we need the plumbing to do. You get aviation to a lesser degree. You get trains, right? So these dialogues still happen, but they're a little bit hit or miss, right, in terms of our coherent approach to them. So there was a general response from both the organizational perspective as well as just the bottom up, a welling up of we need to expose these as APIs, right? So 3GPP, I believe, did our best, and we continue to do our best to make ourselves more modular and exposed for the levers and the knobs to be turned. But really, instead of defining them all at the 3GPP level, what we found was, and this is coming into play even more so for the 6G era, 5G now and the 6G era, the transition, is external SDOs that work closely and liaise with 3GPP have really come to the fore. So GSMA, right? They came in with the open gateway set of specifications and API interfaces to make available to the value creating programmer and analyst and vertical community ways to adjust the levers and the knobs of the underlying network.
Yeah.
But that even wasn't quite enough, right? In the sense that there's also a need that was not being met by us, and that's okay, right? By 3GPP itself, to have reference implementations. And in this case, especially kind of open source reference implementations. So the Camara initiative over at the Linux Foundation started working with GSMA from the Open Gateway APIs perspective. And they created not just a reference implementation, but another forum to really flesh these out and work through with the innovation community, both very, Fortune 50, kind of internal innovation labs, as well as the smallest global startups trying to address this area. And that's part of our plumbing, right? We got the plumbing behind the wall. Maybe that's 3GPP, GSMA, the Open Gateway APIs, plus the Camara effort. Maybe that's kind of the plumbing underneath the sink. And then when you start getting to Camara and of more new effort, this Aduna, if I'm pronouncing that correctly, right, where they can have multi-operator interfaces. These allow, in the 6G era, kind of to a degree, controlled, secure, et cetera, but a bit of a puppeteering of the underlying plumbing towards a given vertical's need or interest. Yeah, it also enables some different business models for billing in different ways, et cetera, and for different content, all of that. But a lot of the most interesting thing for the 6G stuff is that it opens up to verticals, where verticals can define in a more abstract way what the value is, what we really want to accomplish. And they don't have to deal with all of the details of this particular radio access technology, because this works across, it's not just 6G. The idea is that it works across whatever 6G is. And to your point, certain parts of 6G will be really just more like an advanced 5G in terms of the radio interface, is likely to be kind of like 5G was in many ways an advanced, early 5G was an advanced version of 4G, pretty much. I think early 6G will be an advanced version at the radio layer of 5G, right? Delivering on the promises that we made for 5G. But these APIs, a 6G era aspect is HetNet across 6G, 5G, 4G, even within the 3GPP family of radio access technologies. And when you're doing that, those APIs can also, if you abstract them just a little bit more, be applied to non-3GPP family of radio access technologies, right? Whether they come exactly from the same space, to mobile satellite, right? Mobile satellite that integrates closely with through NTN 3GPP, and mobile satellite that continues on its own MSS regulatory track as well as service provision, right? You got maritime, et cetera. Sensing. All sensing is not going to be collapsed into, this 3GPP 6G thing. A lot of it will be treated within that area, but sensing still needs to occur across many different modalities. For the sensing, for the ability to have that connectivity work across all of these different RATs and modalities, probably something at that kind of meta API level, learning a lot from the GSMA Open Gateway, the Camara, and perhaps the Aduna type approaches, where the ecosystem and the other SDOs kind of fill in the blanks of enabling these verticals, to come back to your point, enabling verticals to create value that we down here as plumbers, we simply cannot see. Over.
So, okay, so the plumber in there. So you're seeing in the future as we move forward as being the 6G as being sharing native. So a lot of people talk about being AI native or Open RAN or whatever, and I found that that's kind of a little bit more sort of specific. But sharing native, I think it's an interesting concept because instead of, right now we see the sharing as the exception. So CBRS, you share, but it's just like a special case. But I think that with 6G, what we might move forward, it suggests, is that it's a sharing native. So the sharing is inherent to 6G, is the rule, is not the exception. That it's a fundamentally different approach.
Agreed. Uh, and and there are a couple ways to approach that, at least a couple, right? Definitely the more kind of out of band coarse way that still sort of holds in terms of different regions, different ITU regions within their different regulatory uh, jurisdictions will have their different requirements, right? So at a very coarse level, that kind of sharing still makes sense, right? But when you get down to that sharing native approach, which the definition is open, I would say. Um, by the way, a colleague of mine, Monisha Ghosh, former CTO of FCC, uh, she, to my knowledge, and I'm pretty tied into this dialogue over the years, coined sharing native and sharing native 6G back in like 21 or 22. The concept was there a little bit, but really uh, that the idea of embedding it kind of upfront, the concept, as well as looking at the different mechanisms. There are a number of different mechanisms. We can talk about a few of them, of course, but uh, so that not only is it efficient, but more importantly, it's effective and made explicit. It's brought in instead of some exogenous variable that we all just wonder about and talk about and debate what it means. We bring it in as an endogenous variable to the model and to the system design. So forward looking systems actually take this into account because the gain, the value is potentially huge. It doesn't have to go down to your point at times. You don't have to have the protocols hyper tightly integrated across this rat and that rat to have a sharing native concept. Of course, where it makes sense in specially controlled administrative domains, you may want to have extremely tight uh, integration across different types of radio access technologies, especially when we start talking certain exquisite types of sensing, et cetera, right? But you don't need that to be some concept of sharing native. A couple of these examples, just to bring it back to more concrete kind of system design forward looking, is the quiet periods, right? Whenever we're listening, unless we're talking true simultaneous full duplex within a particular band or subband, the the need to both transmit and receive and to listen, goes back to Ethernet, et cetera, right? But to listen at the same time as you talk, uh, until we get to more of this full duplex approach, which we're never going to be there for everything. Some cases it will make sense. It's moving faster than you might imagine. But we will still have a need to have some sort of quiet period coordination. And in fact, that kind of timing intention aspect that's shared across, for instance, LEOs or GEOs or MEOs, and say 5 or 6G terrestrial, more traditional cellular. That one of the reasons for that is to coordinate in a reasonably fine-grained fashion, but not in a overly lockstep fashion, how we use these quiet periods, because we use those quiet periods for spectrum sensing. We use those quiet periods for not just spectrum sensing, but different types of sensing. So Manisha and her teams, and others, of course, but they have really brought it. Just one example is even before we coordinate the specific MAC protocols, why don't we coordinate and have quiet periods so that the quiet periods don't take away, they add to the overall system. They increase the performance of the overall collection of HetNet system, as well as any one system. Even 6G itself, standalone 6G, can benefit from coordinated quiet periods where the sensing, think of it kind of like a GPS for spectrum, right? In the sense of you can use that to listen to the spectrum. It solves a lot of fundamental communication engineering and communication science, communication theory, back to some of the Shannon pieces. It solves some of these, not entirely, but it releases a lot of the pressure, such that substantial increases in spectrum efficiency and effectiveness, and most important, reliability and resilience, I would say most important, going forward as these become more control oriented and ISAC and sensing oriented. Concepts such as sharing native 6G, just one example being the quiet periods from Manisha and her team. There are other very good ones, right? This ensemble of approaches for sharing native 6G can really help all of us.
Yeah. It's like a very Zen-like, Zen and the art of managing networks kind of thing, in the sense of, sometimes you have to give up something in, like, in this case, like a quiet period that you might say, well, it's a waste of resources, but it isn't, because it allows to manage resources better. So, we usually say, oh, you have to use everything you can. You just do it. Don't waste time. But sometimes it's kind of like maybe initially counterintuitive that you need to take time to coordinate. You make an effort to coordinate, to share. So sharing becomes useful. It's not, it doesn't add to, if that's what you need to move forward and be more efficient.
I think so, more efficient and even more effective. So even inside the core, the core itself, as well as the basic radio access and core technology of the 5G RAN, the 4G RAN 2, we have
Mhm.
measurement periods.
Mhm.
We explicitly, we make it an endogenous variable. These measurement periods and quiet periods, the duty cycle of how the handset and the base stations, and base station to base station too, how they communicate, we explicitly have settings for that, right? So that they can do this coordination you're talking about. Expanding that to more than one radio access technology conceptually is pretty easy. There's engineering to do to make sure it works, but the concept doesn't go away just because it's two different radio technologies.
Yeah, absolutely. And Monisha is absolutely brilliant. I've been talking to her through the years, and, hands down. Um, I wish she was still at the FCC, but that's a different topic. Anyway, Colby, our time is up, but this was a incredibly exciting discussion in terms of what 6G can be. That is just not just yet another G. So I think that was extremely interesting to have this conversation. So thank you so much for sharing your thoughts with us.
Very much likewise, Monica. Good talking with you again. Always a pleasure.
And thank you all for listening to this. Again, this was a little bit more visionary than the usual podcast, and I hope you enjoyed it. And if you did, as I did, and I think Colby did as well, let people know, and so they can enjoy it too. Thank you so much.